And welcome to the next debate here at IPC Apex. It's called the Expectations for Inspection Systems. In recent years, inspection systems have advanced a lot with improved camera technologies, greater computing power, automatic programming, and the ability to inspect shiny devices. Could they be doing more? And what is next for these vital gatekeepers of manufacturing quality and yield? Here to discuss that, we have a distinguished panel. To my extreme left, we have Joel Scutchfield from Co-Young.
Welcome, Joel. Nice to be here.
Next to him, we have Brian D'Amico from Mirtec. Nice to see you, Brian. And of course, next to me, we have Juan Arango from Parmi.
Hey, Trevor. How are you?
Very good, thank you. Very good. So, gentlemen, let's get straight into it. I'll give you my first question, which is: inspection systems have made significant strides in identifying defects with high precision. How do you see the role of inspection evolving beyond just defect detection? Will predictive analytics, process optimization, or inline correction become standard features? Okay, so who wants to take that first? Well, we start on the end with Joel.
Sure, and boy, that covers a lot of ground.
Yeah.
But I think between the three of us, we can probably cover all those bases. I think the most obvious, and we're all involved with it, is the use of the technology for process improvement and eventually defect elimination. Right, using the data to feedback in a self-correcting fashion, so we render ourselves obsolete at some point. Right. Test is really a necessary evil across the board from a manufacturer's perspective, right? There's a cost to everything that a PCB assembler does. So, again, I think helping them lower their costs by reducing the need for human intervention in various aspects of what we do, allow them to better utilize the data that we're providing. Either manually or in an automated fashion to, again, self-correct, all forwards the initiative to improve their yields and improve their cost, and that or drive down their cost, improve their profit, which is really what it's all about. So, again, that's one aspect, and
right.
It's a question that we could answer for hours, right? There's a lot of pieces to this,
okay.
But certainly the process improvement piece is low-hanging fruit.
Okay. So improving the communication between automation tools, basically, and the feedback and the closed loops and that sort of thing is really what you're looking at.
Exactly.
Yeah.
Yeah.
So.
So we sell SPI equipment and AI equipment as well as at Mirtec, and the whole goal is to collect this data, right, and to use that data in a manner that, as Joel was saying, makes the process much more sound, right? We really want to produce boards that don't have defects. And in order to do that, we need to collect that data. You hear AI quite a bit out there, and really what we're doing at that point is we're collecting information that improves the inspection process. And the goal, once again, is to make it so that you're not producing defective boards, and that you're actually relying upon the machines to come back with recommendations as to how not to produce defective boards. Rather than relying upon an operator to make judgments, we'd like to take that information and build upon that information, have the machine really make those judgments. Because what it comes down to is it's very difficult to find someone who has really good process knowledge, especially now. It's difficult to find those people.
Yeah, but the more you can make it predictive, then the more costs you're going to save. You know, the earlier you catch any defect, the more costs you save. So the more you can go towards predictive analytics, the better.
Absolutely. And the key here, and we all have a similar feature, we call it different names, but it's really auto-programming.
Yeah.
And basically what we have done is we've kind of broken it into several stages. And the first one is to generate the program quickly, because our market is more of a high mix, low volume. So if your lot sizes are small and it takes you a day to program, that's a problem.
Absolutely.
So by being able to do that and then crunching the numbers behind the scenes, and like for us at Parmi, the second stage is debugging and the third one is fine tuning. It's basically getting a lot of predictive information, because the other thing that we have in this market is the fact that they're either our age or brand new. There's a middle level that we lost, and that knowledge is what the AI engine has to
Fill.
replace.
Yeah, replace. Yeah, I get it. Yeah. So, I mean, AI-driven automated systems have reduced setup times, as you mentioned, and improved inspection accuracy. But how far are we from fully autonomous inspection systems that require minimal human intervention? And what challenges do we still have to overcome to achieve that? Let's
All right.
Right.
So realistically, I understand the goal here is, of course, to have the machines just do everything, but we really do require human intervention there, and I'll explain a little bit about that. First, what I usually like to do is when customers come to the booth and they say, "Explain AI to me," right? Everybody has this vision of AI being, robots building your boards. It's tough.
It's all in the definition.
It's tough. But what I like to do is I like to bring it into a process that people can relate to very quickly and easily. Like
Yep.
when you're online and you're going out to a website and they want to test whether you're a robot or not, and they say identify the crosswalks, and you're like, that's a crosswalk. That's a smidgen of a crosswalk. Identify the bicycles. Identify the buses. What you're really doing is building an AI engine for the transportation industry.
right.
You're just collecting. You're helping them. They're using your brain to build their deep learning program.
Yes.
And really, that's what we're doing with inspection systems as well. We're building a deep learning engine, right?
So the operator is essentially building that with every
Exactly.
action he takes.
Exactly.
Right.
So when you ask about how far away we are, it depends. If you've got multiple different types of boards and you're doing, like onesie, twosie type boards, and you're using many different types of components, you're really not going to see a lot of iterations of images and defect data to store. If you're building one type of device and you're building thousands and thousands of boards, right, then you're going to be able to build that engine more quickly.
Right.
The more information that you put in, the more feedback that you have to building the deep learning engine, then the quicker you're going to get to the point where the machine's really going to come back and be predictive, 90%, 95%. But it's a really tough question to try to determine exactly.
Yeah, there's always
when.
going to be that bit that is going to throw up an anomaly that's going to need a human to come in at the end of the day and determine what it is or what caused it, because there's so many different nuances in what we do.
And for us, the other challenge is we all have within our systems, we have what I'll call a dashboard.
Yeah.
But our customers, if they use our dashboard, it's just on the inspection side. And what we're getting more requested to integrate with their ERP and MES system,
Yeah.
because then they get the whole scope, and then they have more data to be able to do, as Brian mentioned, to get more images, more data, and crunch the information in a way that it basically, it's still almost Industry 4.0.
Yeah. I mean that is an increasing trend, isn't it, Joel? I mean, where the inspection systems are actually pushing some of that data up to the MES system to do some of the heavy work, if you like, the heavy data crunching, and then heavy lifting, and then send it back down, to give instructions for corrections or whatever. On the line level.
Absolutely, and to kind of finish the point on the movement to fully autonomous, we're basically. I guess you have to really separate that into two pieces. So you have the generative AI piece, which is what we're all involved with today, right? Which is the human input, the human interface, human assist to build the engine, versus the agentic AI, which is autonomous, right? Or Waymo, or self-driving cars. And I think that was kind of what you were asking, right? At what point can we get even to the point of that experience, that evolvement? And as Brian said, I don't know. Yeah, I don't know, because just for instance, just this week, just in a couple different meetings yesterday, 2 different customers, their concerns were not so much about generating the program. It's what happens after that. It's having control within the facility, kind of to Juan's point, for basically test coverage guidance, test coverage verification, program allocation. How do I know, how can I confirm that when that change is made to the program, this is a bit after the fact, how it's deployed, is it just for this run? Is it for all time, basically saving to the permanent library? That's where and again, it comes back to Brian's point that people still are going to have to make critical decisions on how to use what the system is generating. What we can use all the AI. We can use our data sets to build these very robust tools. But at the end of the day, there's still variation, and that doesn't even touch on the part variability and the supply chain issues that go into all the changes. And this is what we've been hearing this week, is that, and it's part of the evolution process, I think, right? We said, okay, we're kind of the point now where on the auto programming side, we're not finished. We're not exactly where we want to be, but we're far enough along that they're starting to ask questions about what comes next. And that helps all of us in developing what we need to.
And I think agentic AI is really, where you want to be heading towards. But as Brian said, you're going to do that quicker if you're you're in a high volume environment and making the same thing all the time. You'll be able to sort of lock that down, that whole process a lot easier. I would think. It's the guys who are doing the high mix. It gets a bit more complicated from that point of view. Yeah. Okay, I want to move on to the next question, which is shiny and complex geometries have traditionally posed difficulties for inspection systems. How have advancements in imaging, lighting and computational methods improved this? And what further innovations do you see coming down the pipe to help with some of these smaller shiny devices that we're getting in advanced packaging environments? I'll start with you, Juan.
Sure. So at Parmy, one of the things that we've done, and we're showing it here, is our new Exceed 2, that our laser, instead of red, is green. Mm-hmm. And the head has a coax lighting, so it diffuses and we don't get the shiny part. And It's been very successful. One of the things that in our head, we process 20,000 frames per second. Mm-hmm. So there's really, in our world, there's really two types of inspection, Morier and laser. And Mr. Huang, who's the owner of Parmy, has been able to use a laser in ways that we never thought a laser would be done, right? So with this type of system, we've basically solved the shiny and the small parts. It's just it's working very well.
It's working well using a laser system. Because your system, Brian, you're using Moiré, that's... You use that, though, to also get around the problem with shiny devices and things.
Yeah, so if you kind of look at the evolution of the Mertec product line, at first we came out with 3D, we came out with white Elcos. Mm-hmm. And then we switched over, and then what we're seeing is basically there's a lot of shiny devices that are entering into, and they're basically wafer-level devices that are now being used on boards. And it's more and more and more. Right. So we're talking very shiny, like CSPs. They look like mirrors. So we end up switching to blue DLP. With blue DLP, there's a difference in wavelength of the blue lighting, which allows us to collect that data. So we see that 3D information, whereas with white Elcos, it basically reflects off. We've taken it one step further with the advent of our new product line, or a new series, which is called the ART system, anti-reflective technology. And what this is, it's the world's first 75 megapixel 5-camera system. So we manufacture our own cameras. We've got 5 15 megapixel cameras, top down, and 4 side angle cameras that are used to collect 3D information. So we are able to see a shiny surface, we're able to see opaque surface, we're able to see anything just because we're using 5 full cameras. So we could deal with light, saturation, blind spots. Many of the Moiré systems out there have got multiple projectors and a single top-down camera that's collecting the 3D data. And what ends up happening is we lose information. We lose it. And then you have to make it up with filtering and, and that's the problem, is when you start doing that and you start, building onto data that's non-existent, then you're really just giving a representation, Yeah, guessing, exactly, guessing.
And like most things that push us forward, it's the customers, it's the market, it's the technology that's forcing us to look at these other avenues, these other mechanisms for being able to see these smaller devices, whether it's a deposit or a bump on a silicon wafer, as Brian said.
What is the Ko-Young methodology for dealing with that? I mean, what technology are you using to deal with identifying shiny devices?
Sure. So the Meister D Plus utilizes the standard Moiré with the assist of the coaxial lighting, right? So that is basically allowing us to suppress the reflectivity. But again, it's a combination of wavelength, angle, again, lighting, all of these things working together. But we've been very successful at doing just that. So we can very effectively find anomalies on a very shiny surface, micro cracks, FOD, all of these other things. We've also had the advantage, because we're quickly moving into that SIMI space of benchmarking against some of the usual suspects on that side, and understanding, what they're doing or what their approach has been to, again, looking at very small, micro bump applications on a very shiny wafer. So that, again, has kind of forced us to take a little bit different approach. That's not standard moire. So again, that's something we'll talk more about as we go forward. But the industry is going to push us in that direction. If we're going to survive, we have to come up with different methodologies for doing that.
Okay. Great. So I think we've addressed that question quite a bit. Let's move on to the next one, which is inspection systems generate vast amounts of data. Are manufacturers fully utilizing this data for process optimization? What are the barriers to seamless integration with MES and ERP systems, and how can they be addressed? Do you think your systems are, passing all the information they could up into the MES and ERP systems, or do you think you could do a better job?
So at Parme, and I think we all do, we can pass the information, but when we're passing to MES and ERP, we're passing what they ask us to pass. So we can recommend, but and then it's however they want to crunch it, and we can advise. But the data's there, so it's a matter of putting the hooks so we can get it to wherever they want it, and then they crunch it. What we see is that not everybody uses the data. And if they're not using the data, then it's an exercise in futility, right? Because as we've all said, you have the data. If you use it correctly, you're going to improve the process, which is our end game, right? We're supposed to be a solutions provider. Yeah. And if they choose not to use the solution,
they're not going to get the benefit of it.
I can't help them there.
Okay. So that sounds like it's more of an education issue.
It absolutely is. And it's almost like you got to teach them or explain to them what the benefits are of using it, because in the end, their process will improve tremendously. Yeah. But it requires a little bit on their part, and sometimes they want it all chewed and swallowed and everything. And, we can only get them to a certain point. But we all have the data. It's ready to send wherever they want it.
So, Brian, when you're selling a system to a new customer, how much training do you give them to show them what capabilities your system really has, so that they take full advantage of it?
Yeah, actually, it's kind of weird because we just did another panel discussion with the same question. So okay, I guess we're interested in getting that answer. What it really comes down to is the whole goal of our machines is to collect data. That's really all we do. We collect data, and then we use that data to refine the inspection process, manufacturing process. Yeah. We want to see less defects. But a lot of customers, some customers will really use that data, and some customers just won't. So you can lead a horse to water and explain exactly what the benefits can be. Yeah. And there are customers that embrace that, and they're just, hardcore, that's what they want. And those kind of customers there, you can show all the bells and whistles and move them towards where they should really go with this equipment, because people are investing a lot of money in these machines, and the capability is there. Right. Some customers really aren't interested. They're more interested in, I just want to make sure I can catch every defect, Want to make sure it's fast to program, I can catch every defect. And I really would sell to whoever wants to buy our systems, but ultimately it's a pleasure working with some customers that really want to deal with all that data and really do get in depth into the solutions that we can provide. Exactly what Juan was saying.
And would you? Is it a case of they need to write more detailed test instructions?
Well, it's an education. It really is an education, and we can educate the customer, explain exactly what we can. Yeah. One thing that we're really good at is explaining exactly what our machines can do. That's how we sell machines, right? And you know what? Sometimes people are looking at this as maybe future proofing. This is what you can do in the future, and some customers embrace that right away. Right. So we do our best to educate the customer as much as possible. Then beyond that, it's kind of up to them, right? And we'll hold their hand along the way, not to be condescending in any way, but we'll hold the customer's hand along the way and show them exactly what the machine can do, to help improve their process, but realistically, they're the ones that have to make the decision that they're going to do it as well.
Okay. We're starting to run out of time, so I'm going to move on to the last question very quickly. Okay, I'll let you start first.
I had a good
Joel.
answer for that one, but we'll save that for next time.
We'll talk about it later.
That's right, no worries.
I'm sure. Okay, with rapid advancements in manufacturing, how should customers future-proof their investment in inspection technology? Are modular upgrades, software-driven improvements, or AI-based adaptability the key to long-term value? So I know you guys all want to sell a new machine, but I mean, how much do you support the customer in the field with, new modules or upgrades that they can take to their systems? Let you start on that one first.
Yeah, well, there's no doubt, Trevor, and I think we all agree that the hardware will continue to evolve as needed, right? We've seen that. Brian's got a 75 megapixel camera, et cetera, et cetera. We've done things on the mechanical side with changes that we've made. But at the end of the day, it's really partnering with a provider that can allow you to attain whatever level of smart factory you wish. To some customers, it's simply auto changeover and traceability. I want to know if I get a return, when was this product made? Blah, blah, blah. To others, it's much more elaborate than that, right? And so, at the end of the day, we still have machines running out there. We all have old machines out there, but, going back to 2004, 2005, when the SPI tool was originally released, now we don't support it anymore, but the software can still be upgraded, right? So we basically, using that concept as we go forward, I had one of my reps tell me this. Juan may remember this story. What a customer actually said to him, "Oh, this is great because I bought this machine, and 10 years later, it has all these new functions, right? But it's the same machine, right? So continuing to iteratively improve the GUI, and now with the use of AI, creating more effective and powerful tools. And again, that's the partnership, right? You're not just buying an SPI today. Right. If you're doing it the right way, you're looking to partner with somebody that's going to be able to do everything that you potentially may need to do down the road.
You're buying a machine, but you're constantly upgrading it. You're constantly providing software upgrades and things like that, and maintaining a good relationship with the customer, of course, and that type of thing. Anything to add?
All right, so the goal would be to make everything so it's backward compatible, but it's really difficult to do that. Software-wise, we can achieve that, I don't know, maybe 80%, 75%, but if there's a big leap in technology, then you really can't get there from here. Right. To go from 2D to 3D, you can't get there from here. There are opportunities to upgrade to 3D, collect the information or use the information that we collected with 2D. But then when you start changing optic systems, going from like a 5 meg camera to a 25 meg camera, we just introduced a 50 megapixel camera. It's not backward compatible. So, unfortunately, there's going to be times when you do make changes to the hardware that simply don't make it conducive to, going and being backward compatible.
Right.
Having said that, our job is to really provide customers with a pathway. First of all, if you get a customer and you do a really good job with them, right, you take care of them, they get the most they can out of the machine, then there's a really good chance they're going to continue to buy from you. And as your machines do become, as they evolve, they're going to continue to buy equipment from you. We'll do trade-ins with customers, etc. But it's really difficult to achieve 100% backward compatibility. I don't think there is any vendor out there that does that.
I think it's hard with the hardware side of it. Because it's the difficulty is it's like if you're putting more hardware in, or like a 50 megapixel camera into an old system, it's going to slow it down so much.
Fit. No.
Yeah, exactly. Yeah, so you really, there are difficulties there, but certainly there's no issues doing the software updates. But last word to you, Juan.
So we all have that same thing. You can take it to a certain level, and when you upgrade in software, and sometimes the databases have fields that the last one didn't have, and then the incompatibility. So, but to Brian's point is, if you're taking care of the customer and you're constantly updating him of the things that you can do to help him, and we can all change the lens or the resolution, so you can get it to a certain level.
Right.
But sometimes you have to I guess, end of life is what we all call it. If you can't get parts for that, that's where it ends.
That's the end of the
And
road.
to their point, and maybe that's a trade-in.
What is the average lifespan of an inspection system?
I would say 15 years they're lasting.
Machines out there. I've been in business now for 21 years, and I have machines that are still running out there, and people are still using them. I mean,
Right.
they last a long time. There's not a lot of moving parts to an AOI system. It's not like a pick and place machine, quite frankly.
Even less to an SPI.
Yeah, exactly. so it's, and actually, I always say, kind of like my biggest competition is my own products. It's
Right.
good stuff, but that's the nice part about it. It's nice for the customer, but yeah, think about that. 21-year-old system still out there.
But the key to all of
they're
us
pumping
is the
data out.
support organization. And we all have a great support organization that keeps those things alive.
Yeah, yeah. I can see that, and it's been great learning some of these things today. And I want to thank all you guys for coming in and talking to us today. But we're running right out of time.
Thank you, Trevor.
Thank you for coming in, Joel. Thank
Always
you,
enjoy
Brian.
it. Thank you,
you,
gentlemen.
Juan.
Yeah, always
And
good
thank
to
you
talk
to our
with these
audience.
guys.
And we'll be back with our next program in a few minutes' time.